To solve this page, we need to remember what these words mean. What is chiral, achiral, and meso? A chiral compound has a non-superimposable mirror image. It will have it can have more than one asymmetric center, but typically if there's one asymmetric center, it will be a chiral compound. When it has more than one asymmetric center, you have to find out if it's chiral, achiral, or meso. So here we have one asymmetric center, one chiral center. Therefore, this is a chiral compound. Same with this one. Now you can also write out or draw out the mirror images and see that they're not superimposable. That might be easier to see with your model kit. This has one asymmetric center. It is a chiral compound. And I'm just going to go through and circle and mark the asymmetric centers here. So these are chiral compounds. You see the chlorines on either side here. You can't rotate this around and get the same configuration. So this, although it has two asymmetric centers, and these are the same compounds, but they are chiral. And that is because, and I'm just going to draw the mirror image real quick. So here I have my chlorine and my hydrogen, and here I have my hydrogen and my chlorine. So I can't rotate this around and get this in order to superimpose. I can't just turn the molecule and make it fit. Because if I rotate the molecule around horizontally so that this carbon is this carbon, then what happens is the chlorine is coming out towards me. And that doesn't help. So these are chiral compounds because they have non-superimposable mirror images. This does not have an asymmetric center, and it doesn't have an asymmetric center because it has two of the same groups. This is not an asymmetric center. It has two methyl groups. Similarly, this is not an asymmetric center, so it doesn't have an asymmetric center. It's achiral. Here we don't have an asymmetric center, or a chiral center, and here we don't as well, because if you look straight down this molecule, each side here is the same. So this is achiral. This molecule has a superimposable mirror image. And you can see that by drawing out its mirror image and seeing that I can take this and put it directly on top. Another way to see that is this line of symmetry right here. So because the one side is exactly the same as the other, this is a meso compound because its mirror image is superimposable. This is the same compound as this. It's just a different configuration. We've just turned around this single bond. So this is a meso compound, and these are equivalent. So let's move this up just a bit. 44. So we have these two asymmetric centers. I'm going to draw the mirror image. This is a chiral compound. It has a non-superimposable mirror image. Regardless of how you rotate around any of these single bonds, you can't come up and make a superimposable shape. So this is a chiral compound. Its mirror image is non-superimposable. Same for 45. So there's the mirror image. If I turn it around this way to try to put the BR and the CL that puts the BR and the CL to the back and the H's come out forward, I can't rotate around this in order to make things line up. So this is a chiral compound despite having two asymmetric centers. Let's see, 47 and 48, these are the same compound here. Notice how you have one of the OHs above the ring in 47 and one below, and they're on adjacent carbons. That's the same for 50. You have adjacent carbons. One is above and one is below the ring. So these are different representations of the same molecule. There is not a line of symmetry here. And if I draw the mirror image, I can't superimpose the mirror image onto the original. So these are chiral compounds. And they're both chiral compounds because it's just two different ways to show the same compound. This has a mirror image. This is a meso compound, and it turns out that these two are the same compounds. Notice how the OH is above the ring on two adjacent carbons. Two adjacent carbons, this is above the ring, this is above the ring. So this is also a meso compound. So lastly, we have number 48. 48 does not have a line of symmetry, so let's draw out its mirror image real quick. So we have CH3 and we have an OH here. And you're not going to be able to rotate this around anyway to make it fit on top or be superimposable. So this compound is chiral.